Grounding for square boxes requires adherence to the National Electrical Code, specifically Article 314.16, which outlines acceptable grounding methods. Let's discuss the grounding tail method. A grounding tail involves using a separate grounding conductor, sometimes called a pigtail, connected to the grounding screw within the box. This tail extends outward to connect to other grounding connections within the box. Next is the bonding jumper method. A bonding jumper is a length of equipment grounding conductor that connects the box to an acceptable grounding point inside the box. This could be a ground screw, a mounting bracket, or another listed device designed for grounding. This method is typically employed when the box isn't securely fastened to the mounting surface with screws or bolts. Now let's discuss the method of stripping wire and attaching it directly to the ground screw. This involves stripping approximately 1 inch of insulation from the grounding conductor where it enters the box and then wrapping that bare wire around the ground screw. While this practice isn't explicitly prohibited by the NEC, it's generally not considered the best practice and local inspectors might not permit it. Let's compare the advantages and disadvantages. Firstly, let's discuss the stripping wire method. The advantage is it is a fast and easy method. It also requires no additional materials. However, there are a few disadvantages. It may not provide a secure electrical connection. Repeated tightening of the screw can weaken the conductor. Furthermore, it may not align with the recommended grounding methods outlined in Article 314.16 of the NEC. Now let's discuss the grounding tail method. The advantages of this method is it meets the NEC requirements for grounding. The grounding tail offers a secure and reliable electrical connection. It also allows for straightforward inspection and maintenance. The disadvantages include requiring additional materials for the tail, and the installation can be more time-consuming compared to simply stripping the wire. In conclusion, the recommended approach for grounding for square boxes is to use a grounding tail that is connected to the ground screw. While stripping the wire and directly attaching it to the ground screw is not strictly forbidden by the NEC, it is not considered the most effective approach and could potentially face rejection by local inspectors. The grounding tail method provides a more reliable and code-compliant solution, promoting electrical safety and facilitating future maintenance or inspections. Grounding, in general, is essential for electrical safety. It provides a low impedance path for fault current to return to the source, allowing overcurrent protection devices like circuit breakers or fuses to quickly operate and clear the fault. This prevents dangerous voltage buildup on metal parts of electrical equipment, reducing the risk of electric shock. Proper grounding ensures the reliable operation of electrical systems by minimizing electrical noise and interference. This is especially crucial for sensitive electronic equipment. When dealing with electrical installations, always consult the latest edition of the NEC and local amendments. These codes provide detailed requirements for grounding and bonding to ensure electrical safety. Also be aware that local jurisdictions may have additional requirements or interpretations of the code. Always check with the local electrical inspector for clarification. Grounding and bonding are closely related but distinct concepts. Grounding connects the electrical system to the earth, while bonding connects non-current carrying metal parts together to create an electrically conductive path. Both are necessary for effective electrical safety. When making grounding connections, use appropriate connectors and hardware that are listed for the purpose. Ensure that all connections are clean and tight to minimize resistance. Regularly inspect grounding connections to ensure they remain intact and effective. Look for signs of corrosion or damage and repair any issues promptly. It is vital to use the correct size grounding conductors as specified by the NEC. The size of the grounding conductor is determined by the size of the overcurrent protection device protecting the circuit. When working on electrical systems, always to energize the circuit before making any connections. Use appropriate lockout-tagout procedures to prevent accidental re-energization. Personal protective equipment, such as insulated gloves and eye protection, should always be worn when working with electricity. Understanding the different types of grounding systems is crucial for proper installation. The NEC recognizes several types, including grounded, ungrounded, and impedance-grounded systems. Each type has its own specific requirements and applications. For example, a separately derived system, such as a generator or transformer, requires its own grounding electrode system. This ensures that the separately derived system has a low impedance path to ground, independent of the main service grounding system. Ground fault circuit interrupters, commonly known as ground fault circuit interrupters, are an important safety device that protects against electric shock. These devices monitor the current flowing in the circuit and quickly trip if they detect a ground fault. Ground fault circuit interrupters are required in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. Surge protective devices, known as surge protective devices, protect electrical equipment from voltage surges caused by lightning or other transient events. These devices divert the surge current to ground, preventing damage to sensitive electronic equipment. When installing surge protective devices, it is essential to follow the manufacturer's instructions and ensure that they are properly grounded. Electrically continuous metal raceways, such as conduit, must be bonded together to provide a continuous ground path. This ensures that any fault current can safely return to the source. Bonding can be achieved using bonding bushings, bonding jumpers, or other listed methods. The grounding electrode system typically consists of a ground rod, ground plate, or metal water pipe that is buried in the earth. The grounding electrode provides a connection to the earth, allowing fault current to dissipate safely. The NEC specifies the minimum requirements for grounding electrodes, including their size, material, and installation depth. In addition to grounding conductors, bonding conductors are used to connect non-current carrying metal parts together. Bonding conductors ensure that all metal parts are at the same potential, reducing the risk of electric shock. The NEC specifies the minimum size for bonding conductors based on the size of the circuit conductors. When installing grounding and bonding conductors, it is important to avoid creating ground loops. A ground loop occurs when there are multiple ground paths, which can create circulating currents and cause electrical noise. To avoid ground loops, use a single-point grounding system and ensure that all grounding and bonding connections are properly made. Regular maintenance of grounding and bonding systems is essential to ensure their continued effectiveness. Inspect all connections for corrosion or damage and tighten or replace any loose or damaged hardware. Testing grounding systems periodically can help identify potential problems before they become a safety hazard. Ground testing involves measuring the resistance of the grounding electrode system to ensure that it meets the requirements of the NEC. Grounding is not only important for safety, but also for the proper operation of electronic equipment. Proper grounding minimizes electrical noise and interference, which can improve the performance of sensitive electronic devices. Shielded cables are often used to reduce electrical noise and interference. The shield is connected to ground, which helps to block electromagnetic interference from entering the cable. In some cases, isolated grounding systems are used to provide a clean ground for sensitive electronic equipment. An isolated ground system separates the grounding conductor for the equipment from the building's main grounding system. This helps to minimize electrical noise and interference. When working with electrical equipment, it is important to be aware of the potential hazards of static electricity. Static electricity can build up on non-conductive surfaces and discharge to grounded objects, causing damage to electronic equipment or even causing a fire. To prevent static electricity buildup, use anti-static mats, wrist straps, and other grounding devices. Electrical equipment that is used in hazardous locations, such as areas where flammable gases or vapors are present, must be explosion-proof. Explosion-proof equipment is designed to contain any internal explosion, preventing it from igniting the surrounding atmosphere. Explosion-proof equipment must be properly grounded to prevent static electricity buildup and ensure that any fault current can safely return to the source. When grounding electrical equipment, it is important to consider the type of equipment and the environment in which it is used. The NEC provides specific requirements for grounding different types of equipment, such as motors, transformers, and generators. The NEC also provides specific requirements for grounding equipment in different environments, such as wet locations, hazardous locations, and healthcare facilities. Grounding is a critical aspect of electrical safety and should not be taken lightly. Always follow the requirements of the NEC and local codes and consult with a qualified electrician if you have any questions or concerns. Proper grounding protects people from electric shock, prevents damage to electrical equipment, and ensures the reliable operation of electrical systems. It is important to remember that electrical codes and standards are constantly evolving to reflect new technologies and best practices. Staying up to date on the latest requirements is essential for ensuring electrical safety. Continuous education and training are vital for electricians and other electrical professionals. These programs provide the knowledge and skills necessary to install and maintain electrical systems safely and effectively. Many organizations offer certifications for electricians and other electrical professionals. These certifications demonstrate a commitment to professionalism and competence. When hiring an electrician, it is important to choose someone who is licensed, insured, and experienced. A qualified electrician will have the knowledge and skills necessary to install and maintain electrical systems safely and effectively. They will also be familiar with the NEC and local codes. It is always a good idea to get multiple bids before hiring an electrician. This allows you to compare prices and services and choose the best option for your needs. Be sure to ask the electrician for references and check their online reviews. Before starting any electrical work, it is important to obtain the necessary permits. Permits ensure that the work is done in accordance with the NEC and local codes. Your local building department can provide information on the permit requirements in your area. Always follow the manufacturer's instructions when installing electrical equipment. Improper installation can void the warranty and create a safety hazard. Never attempt to repair electrical equipment unless you are qualified to do so. Electrical repairs should be performed by a licensed electrician. Regularly inspect your electrical system for any signs of damage or wear. Look for frayed wires, loose connections, and cracked outlets. If you find any problems, contact a qualified electrician to make the necessary repairs. If you are not comfortable working with electricity, it is best to leave it to the professionals. Electricity can be dangerous, and it is important to take all necessary precautions to avoid electric shock. Remember, electrical safety is everyone's responsibility. By following these guidelines, you can help protect yourself and others from the hazards of electricity. The information provided in this narration is for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before performing any electrical work. It is also very important to distinguish the role of the grounded conductor, often called the neutral, from the equipment grounding conductor. The grounded conductor carries current under normal operating conditions, providing a return path for the electrical circuit. The equipment grounding conductor, on the other hand, does not carry current under normal conditions. Its primary purpose is to provide a low impedance path for fault current to return to the source, allowing the overcurrent protection device to operate quickly and clear the fault. These are two separate conductors and should not be confused. The NEC provides specific requirements for identifying grounding and grounded conductors. Grounding conductors are typically bare or green in color, while grounded conductors are typically white or gray. It is important to use the correct color coding to ensure that electrical systems are installed safely and correctly. In addition to grounding and bonding, surge protection is an important aspect of electrical safety. Surge protective devices protect electrical equipment from voltage surges caused by lightning or other transient events. These devices divert the surge current to ground, preventing damage to sensitive electronic equipment. Surge protective devices are available in a variety of types and sizes, and it is important to choose the right device for the application. They should be installed at the service entrance and at any sensitive electronic equipment. Regular testing and maintenance of surge protective devices is important to ensure that they are functioning properly. Another important aspect of electrical safety is arc fault circuit interrupters. Arc fault circuit interrupters are designed to protect against fires caused by arcing faults. Arcing faults can occur when there is a break in the insulation of a wire, which can create a high-temperature arc that can ignite nearby materials. Arc fault circuit interrupters are required in many areas of the home, including bedrooms, living rooms, and hallways. When installing arc fault circuit interrupters, it is important to follow the manufacturer's instructions and to test them regularly to ensure that they are functioning properly. Electrical inspections are an important part of ensuring electrical safety. Electrical inspections are typically required when new electrical work is performed or when a building is sold. The purpose of an electrical inspection is to ensure that the electrical system is installed in accordance with the NEC and local codes. Electrical inspectors are trained to identify potential hazards and to ensure that electrical systems are safe and reliable. If you are planning to have any electrical work done, it is important to contact your local building department to find out if a permit is required. Permits ensure that the work is inspected and that it is done in accordance with the NEC and local codes. Working with electricity can be dangerous, and it is important to take all necessary precautions to avoid electric shock. Always energize the circuit before working on it and use appropriate personal protective equipment, such as insulated gloves and eye protection. If you are not comfortable working with electricity, it is best to leave it to the professionals.